I want to take a look at a special transposition cipher known as the Rail Fence Cipher. And what we're going to do here is we're going to encrypt this message right here and make it so that it's not readable by humans. This is how messages are sent securely over the internet or through text messages on your phone. And this is how information is stored in a database, so that if, for example, somebody got into the database that wasn't supposed to and they were able to retrieve data, they wouldn't be able to read it very easily. Now, in the real world, these messages are not only hard to read for humans, but they make them very hard to read for computers as well. So the Rail Fence Cipher is a simple encryption method, but it's going to teach us a lot here. So here's the basic idea. I want to take this message and I want to split it up into even and odd indices. If you watched one of the previous videos, you saw that strings have indices. This is the 0th index of my string, the 1st index, the 2nd index, the 3rd, etc. The 3rd is this space right here. So the whole idea with the Rail Fence Cipher is that we're going to take all of the odd characters and put them in a single string. We're going to take all of the even characters in a single string, and we'll concatenate the two. And so here are all of my odd indexed characters, all the evens, and the ciphertext is going to be this thing right here. And you'll see that this is not readable. Okay, so how would we implement something like this? The way we implement this is with a function. I'm going to call it scramble to encrypt. And our function should take a plain text message as a parameter, and it should return a ciphertext. So the first thing that I can do is I can actually call my function so that I've got something to work with. My function call is going to look something like this. Now this is going to pass my plain text message to scramble to encrypt, and I'm going to iterate through this message like so. Now for CH in plain text, this is going to iterate through each character of my plain text message one at a time. So I named it CH, or character for short. And for now, why don't I just print CH so that I can see what I'm working with? Now, I'm not defining ciphertext yet, so we'll see when I try to return it, it's going to give me a little error, but that's okay. Let's look at the output of this program so far. Okay, and you see what it did is it looped through my plain text message and printed one character at a time to the screen. That's what I was expecting. And then we get name error, ciphertext is not defined. And I agree, it was not. So the next thing we want to do, remember we're going to be splitting these into the odd characters and the even characters. So I need a way to determine if these are even or odd. It would be really nice if I had a counter so that I could see what index I'm on. So I'm going to define a separate variable here. Let's just call it char count or character count. I'm going to initialize it to 0. And at the end of every run of my loop, I'm going to increment this by 1. Okay. And why don't I just print char count alongside the character there, and it's going to show me the index of each character. And we're going to run it right now to verify that we're working with what we think we are. Okay, and this looks good. So T is the 0th index, H is the 1st, etc. And you see these blank spaces, those are indeed characters, and so they're counted as well. Now I need to think of a way to split these up into even and odd characters, right? So if you don't remember the modulus operator, let's take a look at how it works real quick. The modulus operator gives us the remainder after division. So if, for example, I did 10 mod 3, when I do 10 divided by 3, the remainder is 1. So it gives me that answer. If I did 10 mod 7, the remainder is 3. I get that answer. And 15 mod 7, well, 7 goes into 15 twice with 1 left over, so there's my answer. Now it turns out that 15 is divisible by 3, right? So the remainder after division is 0. And we're going to use that fact to think about even and odd numbers. Every even number is, of course, divisible by 2. So 15 is not even, and it gives me a remainder of 1. However, 16 is even, and it gives me a remainder of 0. So every even number is going to have a remainder of 0 after I divide by 2. And that's how we're going to tell the difference between even and odd numbers. And this is how you tell the difference between even and odd numbers in almost any programming language, not just Python. So let's come back here. So char count is going to help me decide if I'm on an even or an odd index. So I'm going to just comment this out right here because I only needed it to get oriented as I'm writing this function. But if char count is an even number, then that would mean that char count mod 2 is 0. Okay? So this means I'm on an even character. If char count mod 2 is 1, that means I'm on an odd character. However, a number is either it's even or it's odd and nothing else. So I can replace all of this right here with a simple else statement. If it wasn't even, it must be odd, and that's going to throw me into this code block right here. Okay, so let's think again about what we want to do if it's an even character. If it's an even character, I want to start adding it to a string over here. I'm going to use concatenation to achieve this. So this is going to look a lot like the accumulator pattern. In fact, it is the accumulator pattern with strings that we did before. So this is, let's define something here. Even chars, and I'm going to set it to something empty just like we did with the accumulator pattern. And here, once I know that I'm working with an even character, I'm going to add that character to my even char string. So there we go. I just concatenated that character on there. It's going to build it up one character at a time. And I'm going to do something very similar with the odd characters. Okay, I'm going to clean up a little bit here. Don't need this anymore. And hopefully this works. So why don't I just, outside of my loop, print the odd characters, print the even characters, and I can verify that I've ended up with what I was going for. Uh-oh, ciphertext is still not defined. Why don't I just comment that out for a moment? Okay, so here were the odd characters, H blank UC, and here are the even characters, TEQ. And I think that's what I was going for. So far that looks pretty good. Why don't I actually build this ciphertext string now? So it's this simple. It was the odd characters plus the even. We're concatenating them. Now I can return ciphertext, and this is going to behave as expected. So this line right here is essentially going to evaluate to this string that I'm returning ciphertext. Why don't I instead name that MSG for message, and I can print message to the screen now. And let's see if I got what I was going for. Okay, H blank UC yada 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 DG. H blank UC yada 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 DG. I think I did it. So this is the Rail Fence Cipher with 2 rails. We can actually implement this with 2, 3, 4, 5 rails, as many as you want, and that is left as an exercise.